Hi everyone, Architecture Operating Systems. We are in week 9 and this week I'm going to introduce another technique for Boolean algebra simplification. In the previous 2 or 3 weeks, we discussed Boolean algebra and using different rules and laws such as De Morgan's and so many other rules like distributive, associative, and so many others. We learned how to simplify the Boolean algebra and digital circuits. In this week, I'm going to introduce another technique, which is called Karnaugh Map, and seems to be easier from different perspectives than other technique that we used in previous weeks. So what is Karnaugh Map? Karnaugh Map, as you see here, it's another method and representation and arrangement of the truth table. So what I mean? For example, look at this one. This is an OR gate. This is an OR gate. This OR gate, as you see here, this is OR gate, not AND gate, definitely. This is OR gate. Let me erase this bit for you. Yep. So this is an OR gate. For this OR gate, we've got two inputs, A and B. A can be 0, 0, the output will be 0. As you see, so we've got A and B, and we can create this truth table based on this OR gate and the output of that. Karnaugh Map tries to represent this table, mainly the output of this circuit, in another way, as you see here. So, for example, if you want to form this truth table in form of K-map, what you need to do, you need to put the inputs outside of this box, this table. So how many inputs we have here? 2. One of them is A, for example. The other one is B. So A, what are the values that you can have? Can be 0 and 1. B, 0 and 1. A and B, no difference. Actually, I can make it A and B here, same as the other one, A and B. So look, this cell shows the output of this circuit when input B is 0, input A is 0. It means that 0, 0, we are talking about the first row. So 0, 0 is 0. Next one, A is 0, B is 1. A is 0, B is 1. We are talking about this cell. 0 and 1. For OR gate, we have 1 as an output. Next one, 1, 0. 1, 0. A 0, B, A 1, B 0. Here is the output 1. And 1, 1, which is A and B, both of them are 1. We are talking about this cell. When both of them are 1, the output is 1. So as you see, we convert this form of truth table into new representation for K-map. So the first step is to create this K-map, this table, new table. As you see here, this table works based on only the outputs of ones. Zeros are not important for us. Zeros are not important. Only these ones are important. So imagine that if you have a bigger circuit with more than 2 inputs, so it would be very hard to create the truth table using all the different permutation of the inputs. But in those circuits, this output 0 is not important. We've got to only find the outputs of ones for them because we want to create only the ones in our truth table. So before I actually introduce a technique to solve this problem and make it easier, it's good to see if you have more than 2 inputs and how to create a Karnaugh map for that. So if you have 3 inputs like A, B, and C, as you see here, I drew it here, A, B, and C. A, B, and C. So C can have 2 values only. C can have 2 values, 0 and 1. We always start with 0 and then 1. What about AB? AB, we've got 2 values for each, so we've got 4 different permutations of binary numbers for that, 0 and 1. Look guys, you've got to always follow the way that I'm telling you. If you use any other method, any other way, any other order of these 1 and 0s, you will get wrong answer. So what you've got to do, always start with 0, 0, 0, 1. It means that A0, B0, A0, B1, 1, 1, and 1, 0. Again, I echo what I just said. We've got to always follow this order. If you write 0, 0, 1, 0, 1, 1, 1, 0, 1, something like that, you will get a wrong answer using Karnaugh Map. So the order is very important. Don't make mistakes. We always follow that. So what if you have 4 inputs? If you have 4 inputs, okay, it doesn't matter. 2 of them together, 2 of them together. So again, the same order is used. Same order is used. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So we've got actually the scope of this module for Karnaugh Map is using maximum 4 inputs. So either you've got 2 inputs, 3 inputs, or 4 inputs. This is the tables that you've got to use to create the K-maps. So these are the K-maps. We know how to construct K-maps, but the most important thing is that how to find ones. If you want to find the ones, I introduce a technique which is called SOP form or subform. What is subform is called sum of products. It means that what we've got to do, using distributive rule, we've got to get rid of all the brackets. We've got to remove all the brackets. Look at this, the example that we have here. This is CD plus B AND gate A. In distributive rule, we said that we can multiply this A by all of them and we get ACD plus AB. As you see, this is sum of products. These are products. This is sum. This is sum of products. So for this, why we use this sum of products? Because we using this technique, we convert this one, which is combination of and OR gate, to one big OR gate, because this is sum. And we've got different inputs, which each of them has got AND gate. For example, here I've got 3 input, A, C, D. Here I've got another AND gate. One input is A, the other one is B. So as you see, this circuit will turn to such a circuit that we've got one OR gate because it's sum of products. Look at this, the other example is like that. We've got sum of the products, sum of the AND gates. So we've got one OR gate here and we've got different AND gates. Why is it important to use this method? Because in K-map, we are looking for ones. If you're looking for ones, it means that when at least one of these inputs is 1, the output is 1. So that makes the life very easier for us. Let me give you an example and show you how it works. There you go. This is the circuit that we have. Oops. So what is this circuit? This circuit, if you translate it to Boolean algebra, Boolean expression, you will get that, which is AB plus A, B, C plus B, B, C. So this is not a subform because subform, there is no bracket there. So you've got to use distributive rule to convert it to subform. So it will be AB plus AB plus AC plus BB plus BC. We know that BB is the same as B. I don't need to repeat AB twice, so I get AB. I have AC, BC plus BC. There you go. This is the subform. This is something that we are looking for K-map. Why? Because now I know for this one, I've got 3 inputs. For 3 inputs, I can create this K-map. A, B, and C. I've got 3 inputs. So inputs 0, 0, 0, 1, 1, 1, 1, 0. And 0, 1s are the inputs for the C. But which cells are 1? We are looking only for ones in K-map. How to find them? Look guys, subform helps us to find the ones. Why? Because I know that when any of these inputs, any of these products or AND gates is 1, When any of them is 1, the output is 1 because that's a big OR gate with 4 inputs. When one of these, at least one of these inputs is 1, the output is 1. So subform helps us to understand that. How? Look, when AB AND gate, AB is 1. I know that when A is 1 and B is 1, AB is 1. When A is B1, the output of this circuit is 1. So when A is 1 and B is 1, look, I'm talking about this row. When A is 1, B is 1. Is C important? No, C can be 0 or 1. So I put 1 in both of these cells in this row. Why? When A1, B1, definitely the output is 1. Doesn't matter, C is 0, C is 1. So I did this bit. AC. So when A is 1, C is 1, the output of this circuit is 1. So A is 1, I'm talking about these two rows. C is 1, I'm talking about this. Look, B is not important. B can be 0 and 1. Look, the second number shows B. So these two rows, when A is 1 and C is 1, this column, it means that these two, doesn't matter, I'll have a repeat, but these two ones shows AC. Next one, B is 1. Is C important? No. Is A important? No. Let me delete this one. So B is 1. B is 1 only these two rows. In these two rows, A can be 0 and 1, doesn't matter. C can be 0 and 1, doesn't matter. But B for these 4 cells is 1. So what I do, 1, 1, 1, and 1. Again, doesn't matter, I'm repeating some of the ones, but these are the ones that I get. The last one, BC, it means that B should be 1, C should be 1. B1 here, C1, I'm talking about these two. B1, as you see, these two rows, C1, only these two columns. So this. So it means that using subform, we, instead of going through 8 rows and create the whole truth table, what we do, we go directly find all the ones that we have here. So what we've got to do, create, actually do the find a subform, remove all the brackets, create the table in terms of how many inputs you have, 2, 3, 4, you know how to do the permutation, and find ones. Find ones, it means that go and find when each term is 1. For example, here, A1, B1, because as AND gate, the output is 1. A1, B1, we are talking about this. C is not important. I will solve more problems and you will see how to. Okay, I created that. But how to solve the problem? How to simplify that? Simplification in Karnaugh Map is based on groups, grouping, how to group the ones. It's all about groups. There are some rules, very easy rules. I'll go over the rules quickly. You will learn them. First of all, the first thing, zeros are not important. I even didn't write the zeros here. The ones are only important. So zeros are not important. We cannot group the zeros with ones. So this is wrong. Why? Because I'm grouping 0 and 1 together. This is right, because I can group 2 ones together. I'll tell you how to use these groups later. But first of all, we've got to learn how to group the ones. Can I group them in diagonal way? No. You've got to only group in horizontal and vertical, horizontally and vertically. So these two can be grouped. These two can be grouped, but these diagonal ones is not acceptable. We cannot use that. This is the second rule. The other one, which is very important, okay, how many ones I can put in one group? Look, this is the binary, we are talking about the binary numbers. It can be the group size can be 2 to the power n, 2 to the power 0, 2 to the power 1, 2 to the power 2, 4, 3, 4, and so on. It means that groups can be group of 1, group of 2, group of 4, group of 8. Can I have group of 3? No, that's wrong. You cannot use this group. Group of 2? Yes, I can have. Group of 4? Yes. 2 to the power 2 is 4. Group of 5? No. What about group of 6? No. 7? No. 8? Yes. The biggest group that you can have is group of 16. in this module, because you can have 4 inputs and the biggest group can be group of 16. So the groups can be 1, 2, 4, 8, and 16. These are the group size. So the groups should be as large as possible. For example, here, I can make a group of 2 together because, yes, you said that you can have group of 2. Another group of 2 here, but I said you've got to go for the biggest group. If you can make a group of 4, you've got to go for that. Making group of 2 is wrong here. Look at these two. Can I make group of 4 instead of 2, 2? Yes, you've got to go for group of 4. So this is the right thing. You've got to group these 4 together. You've got to group these 4 together. But far they've got overlap, doesn't matter. Overlap is acceptable. If you have overlapping issue, there is no problem here. Group overlap is okay. So as you see here, look, you can create group of 4 here. You can group of 4 and you can overlap them. So this grouping is wrong. This is the right way. And this one, which is very important, is that we need to look at these K-map tables in a 3D way. You should be able to see them as a cylinder. So you can wrap around the table. It means that these two and these two, if you look at that as a cylinder, these two together and these two together will be adjacent. So you can group of 4. So as you see, you can create a group of 4. In the same way, if you create a cylinder, but in the other way, these two and these two will be adjacent. So as you see, we can create a group of 4 together. You've got to practice more and see how you can actually group them. Just to write for you here, it means that you can create a group like this. When I said that wrap up, it means that ones will be actually sit next to each other, or you can group them in this way. Look at the table in this way. Again, as you see, ones will be adjacent here and we can make the group of 4 here. This is what I just explained there. So wrap round table is something important that you need to know and learn. And the last one is there should be a few groups as possible. So look at this. Again, you've got to go for the biggest group, you've got to go for the overlap, and you've got to go for the fewest group possible. Here, if you go for group of 2 with no overlap, you've got 3 groups. But if you go for group of 4 and having overlap, you've got 2 groups, which is acceptable. Now, I just went through all the groups, and now I want to see how I can group them. Okay, how to group them? Look at, guys, we've got to follow this method. First of all, you've got to go for biggest group possible. I can see these 4 ones together, so I can say this is one group. Yes, you can say for group of 2, you can say group of 2, group of 2, group of 2. But if you can go for the biggest group, you've got to go for that. So these 4 together, this is one group. So can I make a group of 1 here? You can have group of 1, but if you can go for group of more than 1, you've got to go for that. You've got to go for the largest group. So the other group, I can make a group of 2 here. So this is group of 2, and I can use this group. So can I have any more group? No. Fewest group possible, 2 groups, biggest group possible. So these 4 are together, these 2 together. Job done. We group the ones together. Now it's time to find the terms, the simplest form of that. So we've got to see what does this group show and what does this group show. So what about the first one, the first group? So in this group, guys, C is not important because in this group, C, 0 and 1, both of them are acceptable. So C is not important. Come here. A for this group, look, I'm talking about these rows. A can be 0 and 1. It means that A is not important. You don't need to write A because A can be 0 and can be 1. The only thing which is important here is B. B must be 1 for all of these 4 ones. B, this group shows B. When B is 1, you can have this group. All of these ones occurs when B is 1, the input B is 1. What about this? This one, C should be definitely 1. We are in this column. C is 1. Definitely C is 1. What about these two? B is not important because B can be 0 and 1. You don't need to write it because it's not important. A should be 1. This group shows AC. Then you've got to say B plus AC is the simplest form and simplification of this Boolean algebra. So instead of actually using different simplification techniques, using this Karnaugh map, you get the simplest form of that, which is B plus AC. So as you see, guys, K-map is the simplest technique that we can use for simplifying Boolean expression. So in the second video for this part, this lecture, I will give and solve 3 examples using 2 inputs, 3 inputs, and 4 inputs to show you how we can use K-map. Please watch the second video.